tenant timestamp, what is the activity, what is the resource. And if we want to bring in other attributes as perspectives, and I'm going to come back to that soon, then we can mark them as such. So this will allow us, once we discover the map, to actually dynamically switch perspectives. So instead of looking at the activities and how they are ordered, we could look at the roles that are involved, or we could look at the systems that are involved in this loan origination process, if we have that information, right? So I'll leave it as is, and here I can either schedule the pipeline with a periodic cadence, as I was saying, or like in this case, I'm going to do just a one-off import. So say that I put it here. And now the tool will go ahead and will schedule this pipeline to be performed. So once I go then back in my repo, this will pop up here. And here it is, right? So that has just been imported. So now what I can do, I have a log. It is marked by this event log icon. I simply double click on that event log to start my analysis. What the tool will do is to automatically reverse engineer the process map. So you see now that each box represents an activity, pretty much as I saw it in the table of my data set. And each arc represents a transition between two consecutive activities within the same case, right? So here I've got a couple of information that I can already look at. One is the color and the other is the number. The number indeed represents a specific frequency measure that I'm overlaying on the model. And I have a range of frequency measures that I can choose from. And the most common is the case one. That is telling me in how many cases I have observed each of these tasks. So say create application was done in all the 608 loan applications, but analyze application was only done in 374. And the same goes with these transitions. The arcs also have a number that shows how many times within this particular event log that path, that arc has been taken from one activity onto the next. There's a summary of statistics here. You see that I've got 608 cases and 93 different case variants. These are the pathways. These are the possible ways of handling a loan application that I've observed in this data set. Now you see that this number is relatively high compared to that. So that is an indication of the degree of variability of this process at hand. The closer this number is to the number of unique cases, then the less structured, the more ad hoc-ish the process is. So the more it is in need of being standardized, of being structured. I've got also some statistics about the duration, like it's telling me that this log time frame goes from 1st of January until the 14th of October 2020, and that the average duration is 3 weeks, though we've experienced peaks of 3.5 months and a minimum duration of about 11 hours. So that is another important indication of the variance that I have in the duration of this process. While there are cases that on average are performed around 3 weeks, and let's say that that could be consistent with our SLAs of completing a loan application in 3 weeks, I have some cases that take well above 3 weeks, in fact, 3.5 months. So that is a starting point for performance mining, that is to analyze why there are certain cases that take that long. But let's come back to the structure. I was talking about these numbers. The next is the coloring. The darker the blue color, the more frequently I have observed an activity. And the thicker the arc, the more frequently I have observed a given transition between two consecutive activities. So what I can do that here at a glance is just to look at the process. And all these activities that are colored in a dark blue color, as well as the arcs in between, they basically represent the sunny day scenario. The most common path that is followed by the great majority of cases when this bank analyzes and handles loan application. However, we can see that there are some less frequent paths and less frequent activities. For example, here I can amend the application. And that has been observed in 11 cases or in 11 applications. Or here, when it comes to analyzing the offer, I may need more information from the loan applicant because there's missing information. That's very common. And that might be because the triage has not been performed effectively at the onset of this case. Or here, I need to amend the offer. And so on. There are other amendments there. Now, what I can do is to start drilling into these exceptions, or let's say less frequent activities and arcs. So one thing that I can do now is to change the frequency. For example, I could look at the maximum number of times a given activity or arc has been observed within the same case. Now, what you can see from here is that there is at least one case where activity amend offer was performed 12 times. So within the same case, the offer was amended 12 times. And probably within the same case, it was analyzed a great number of times, because every time it is amended, then it needs to be analyzed again. Now, this particular overlay is telling me that there is at least one case that has such characteristics, but it's not telling me how many cases do have a high number of repetitions for this activity. So for that, I need to apply a filter. And filtering is a mechanism that analysts very commonly use in process mining to start digging into specific subsets of our log, basically slicing the log in order to focus on, say, a set of cases that fulfill certain characteristics. And in our case, I want to find out all the cases where the offer was amended more than 5 times, assuming that 5 is the number I can tolerate. So for me, an application or an offer in this case should not be amended more than 5 times. So I go to the funnel up here, and I've got a range of filters that for time reasons, we're not going to be able to see all, but I'm going to focus on one or two. So the one we are interested in this case, is the rework filter. That basically allows me to isolate cases where a given activity has been performed within a range. So the activity that I'm looking at is amend offer, right? Amend offer is here. You see that maximum has been observed 12 times. Now let me say, I want to retain all the cases where that activity has been done more than 5 times, because 5 was my tolerable threshold. Press OK, and I see that this returns only 7 cases. So likely for me, there are only 7 cases where that amend offer has been performed more than 5 times. So I press OK, and now I can see the process map that corresponds to those 7 cases. So the next step is to click on the case inspector here. See, I'm only retaining 1.2% on my entire set of cases. That is 7 out of 608. And here I can actually see the list of those cases where their characteristics. So now you see that we are bridging across compliance, because what I've effectively done is to isolate a number of cases that are potentially non-compliant, because they are violating an internal rule that is that an offer should only be amended maximum 5 times. So I could download a list of these cases and pass it on to my auditor for an offline analysis on top of the system. Or I can handpick the cases. Typically, I would look at a sample, say this case 2 to 3, and look at the timeline of that case. Now, the timeline basically shows the actual sequence of activities that were performed in the context of that specific loan application, that is loan application number 2 to 3. Now I see the activities. For each of them, I see the effective duration, and then I see also the waiting time in between. So if I have a thick arc, that means that there has been a very long waiting time. Now look at this particular case. This particular case has a specific arc that just by itself took over 1 month. So after this offer was amended, the nth time, then before being analyzed again, it was probably being dropped down the bottom of the queue. So it kind of became part of a long backlog for some loan assessor. When you drag over each activity, you can also see all the attributes for that activity, like when it started, when it finished, who performed it. Like you see, this was done by Magdalena Predruta, and what is their role? Like she is a credit officer. Where are these amendment? And that is, let's see this here amendment is being performed more than 5 times. So you can see who did this amendment was Nico. So that is that person, that resource has been violating the internal policy. Okay, and you can do that for a selection of cases. And you see that the overlay here has changed. In fact, we are looking at the actual durations of activities and actual waiting times. And also this statistic is color coded. The thicker and red the color of the arc, the longer the waiting time, the darker the red color of an activity, the longer the activity took. So it was, for example, that particular approved offer was a bottleneck for this case because it took over a day compared to other activities that took a bunch of minutes or hours. Okay, so basically what I did here was to start from the initial structure of my process, have a look at it at a glance and understand what is the common path, what are the exceptions, and then start drilling down into some of these exceptions. And one of those was a number of cases where a given activity was repeated an excessively high number of times. So that basically bridges across compliance, because that I can use it as a starting point if that is a use case I'm interested in to drill down into that particular problem. So as I did, I set up a rework filter. And when I apply the rework filter, then I managed to retain only the activities. For duration, we have a range of duration statistics, and the most common one is the average one. So this one allows me to plot on top of each activity the average duration, and on top of each arc, the average waiting time. So as I said, the darker the red color, the longer the activity takes. So very quickly, I can pinpoint potential bottlenecks like approved offer. I can also, by the same token, identify potential resource capacity bottlenecks when you've got arcs that are long. Like look at this, so arcs whose duration is long, because that indicates a long waiting time. Take a look at this activity, analyze offer. This activity per se doesn't take long. It is in the order, it's performed in the order of minutes, 20 minutes, which is in line with the duration of the other activities. But now take a look at all the incoming arcs into this activity. You see that they are thick, and that is because they have a duration which is on average longer than that of the other arcs. So that is an example of a resource capacity bottleneck, meaning that the resource that is supposed to perform that activity probably is saturated or overutilized. So we've saturated the capacity of that resource, And so once we reach that level, then cases start queuing up at the doorstep of this activity, waiting for the resource to become available and perform. And that is a very typical example of a bottleneck that is originating by the lack of sufficient resources. As you can imagine, there are now different opportunities for fixing this problem. But of course, before doing that, we want to drill down even more. For example, I could accompany this user with a bot. I could try to automate the activity altogether, or more simply, I could increase the capacity of this resource by allocating more units, right? So one thing that I can do is to study these bottlenecks from a dynamic viewpoint. So I can click on the animate button, and basically the tool will quickly compute the pathway of all the different cases as they would flow throughout my model. So what you see here is the timeline of my log, as we said, from 1st Jan until mid-October 2020. And you see an area chart that represents the work in progress, that is the number of open cases at a given point in time. Basically, whenever you have swells, you would expect a higher number of cases. So now I can play, and I'm looking specifically at the period of June. Let's move it a bit forward to July. And then you can really see those bottlenecks in action. Each token, each circle represents a specific case. So this is not just an aggregate or a sample statistics. It is really case by case. So we are reproducing all the cases. And when cases follow the same path at the same speed, then we aggregate them in larger circles to show that there is basically an engrossment of that particular path, like if it was, a flow of water that swells. And basically, you see that especially around that activity amend offer, which, as we saw before from the analysis of repetitions that we did, happen quite frequently. Now you can see that this amend offer and analyze offer, they are part of the problem. I have a resource capacity problem. Nonetheless, the fact that there is a loopback between amend offer and analyze offer leads to this bottleneck being exacerbated by the fact that we go back and forth many times within the same case. Now, while I'm here, BIM is asking whether the waiting time calculation takes into account non-working days. So you see that I've got statistics about the duration. The duration of the activities, what we call processing time, and the duration in the arcs, that is what we call the waiting time. Now, at the moment, the statistics out of the box are not taking into account holidays, non-working days, and also out of timetable periods. So for example, from 5 p.m. till 9 a.m. of the day after. So basically non-office hours. So these 3 weeks represents the end-to-end duration of the process from the time we created a loan application in the system until we implement the payment schedule. However, it might be interesting to actually taking a look at the effective time in terms of business days and working time. So what we can do is to go back to the portal and open this custom calendar property. So here I can create my custom calendar where I can specify my work patterns. I might do a Saturday morning shift. Hopefully we don't. And I can also specify based on my time zone, what are the public holidays? So for example, Victoria, right? So I'm telling the system to recompute all the duration statistics on the basis of this work pattern, Monday to Friday, 9 to 5, and to exclude any public holidays that I've got in Victoria. I pick that, that's my custom calendar. I applied it, and the tool recomputes all the statistics. So when I open my log again, you'll see that now the statistics have changed. So if my analyze offer was taking 23 minutes on average before, now it's taking 4.62 minutes. If my process was taking end-to-end 3 weeks, now it's taking an effective time of 5.08 days. So I can recompute these statistics quickly on the basis of my the relevant business calendar. Okay, maybe at this stage we can pause and take one or two questions before we continue, rather than just me talking. If there is any other question, feel free to ask now, and we can take it from there. Or feel free to write them down in the chat, and as I continue, I read them through and I can answer these questions.
Hi, this is Ben here.
Hi, Ben.
I have a question. I can see on the screen there's a toggle between process map and BPMN model. So does that mean that if we toggle to a BPMN model, there will be like a BPMN?
Absolutely. So
translation, yeah.
At any point in time, I can switch the view between the process map, which is just a low-level representation of my log, where I'm unable to distinguish different types of routing. For example, do we do these activities in parallel, or they are mutually exclusive? To do that, I can switch the view to the BPMN model. And the tool automatically turns this into a BPMN model. The underlying algorithm is called Split Miner and is the result of the work of one of my PhD students. It is quite sophisticated, and as you can see, is also very fast, including for very large models. So again, you can use the BPMN model natively here, meaning that you can change the statistics overlay. You can apply abstraction sliders, meaning showing or hiding more or less frequent nodes and arcs to show or hide details of this process, and change the statistics. So for example, something interesting would be the relative case. So you can see the branching probability, how often you take a branch compared to another, for example, when you have an XOR split. Now, this model is relatively simple, so you only see a bunch of XORs. But Split Miner, as an algorithm, is actually able to discover different types of routing constructs. So if I take a healthcare log, which is a little bit more complex, and I'll show you what I mean. Let me put this, say, here. You see that this can be quite messy. Now, when I switch to BPMN, then the model will be simplified because Apromore is able to discover, for example, AND for parallelism. Let me see here, AND or joins. So different types of gateways. So basically, it would allow me to understand what activities are done in parallels and what exclude each other. Now, while we are on the topic, when I have discovered the BPMN map, the BPMN model, I can also save that back into my repository. I click this button here and I save a BPMN model of my process. So if I go back to that folder, you'll see here my model, right? So I double click in there, and then I will open that with the embedded editor. And this is a BPMN 2.0 editor. So here I could start, for example, modifying this, adding a triage, for example, right? So you can start making changes to your model. Another thing that you would commonly do would be to add pools and lanes to this, right? So start specifying more details in the process. And of course, you can save these models, export, version control, share it, and especially once you've discovered the assist model, then you can start simulating it here. So you see this drawer that I just opened allows me to input a series of simulation parameters that I can then use to simulate different what-if scenarios. So going back to what I was saying, what-if process mining is this capability that allows me to assess the impact of different alternatives. So say that in the context of this loan origination process, we are launching a new marketing campaign. And as a result of that, we expect the arrival rate to increase, that is to receive more applications within the same day. So you want to simulate what would be the impact of that increase in demand on the process performance. Will I still be able to meet my SLA of completing this loan application in 3 weeks? What would be the impact on resource utilization and on cost? So this is what you can do using what-if process mining.
Sorry, Marcello, I've got a quick question. You did mention that you could do a bit of cost analysis here as well?
Yes, so we can do that, for example, in the context of process simulation. So maybe before getting to process simulation, I can show a couple of more points and answer another question quickly. So then we can leave this plugin and move to the process simulation one. So somebody else is asking, can you filter cases with a certain activity on the endpoint or as the final activity on a path? Yes, so there is a range of filters that you can apply, and the specific one that you refer to is called the path filter. Now, I could go back to the filter UI and create the path filter and choose, for example, that I want the case to end with activity, implement payment schedule, right? So there, and this will retain only those cases that finish with that activity. So you see, in this case, I've got 66%. But there is a quicker way to do that. So if I explode the arcs, you'll see that indeed there is this implement payment schedule, and then there is this percentage of cases, 66%, indeed, as we found out before, just applying the filter, that completing that activity. But there are also other cases that are knocked out much earlier, like at approve offer, at analyze offer, at analyze application, etc. So one thing that I can do is to apply shortcuts. These shortcuts allow me, through keyboard and mouse combinations, to quickly apply most common filters. And one is indeed the path filter. So control and right click on this arc to retain only those cases that end with that activity. By the same token, I would be interested in those cases where there is a self loop in approve offer. So control and right click on the self loop to retain only those cases. Right? So I can easily apply these filters to drill down into specific subsets of my log. And I don't need to open the filter interface. I can just use these shortcuts. And once you familiarize with them, you'll see that it's pretty easy to apply these very common filters. Okay, just to finish off on this particular plugin, another thing that I wanted to talk about, to present, is the perspective notion. So you saw that we can dynamically switch from process map to BPMN model. Another action that we can do dynamically is to switch perspective. So remember, when I imported my log, I tagged certain attributes as perspective, the resource and the role. So that allows me to switch the viewpoint of my process and effectively to do really an analysis of the organization and how it participates in this process in terms of resources, roles, systems, applications involved. Anything that my log contains can be used as a perspective if it is a categorical attribute. So I switch to resources, and there you go. Now I see the social network of interactions between the different resources that participate in my process. Those in darker blue are candidates for overloaded, overutilized resources. When I switch to duration, those resources like Francois de Perrier, where all the incoming arcs are thick and slow, they are possible resource capacity bottlenecks. So when I switch the perspective to a resource view, each box represents a resource, but each arc represents the handover of work between different resources, right? So you see that every time work is passed on to Francois, it takes time. Now, Francois is indeed, together with Karel and Magdalena, behind that resource capacity bottleneck that we saw before. And by using these filters, it's actually quite easy to see who's doing what. So I'm going to use another shortcut, Control, Alt, and right-click on Analyze Offer, just to keep that activity. Now, this is not filtering out any case. So I had 544 before. I'm still showing the same set of cases. But I'm just hiding the details. I only want to see Analyze Offer. That is because when I move to the resources, then I'm only going to visualize the resources that are involved in the execution of that specific activity. With their performance or their frequency or their relative case frequency, etc. Right? So you can easily move between perspectives. They would have all the same role. In this case, is credit officer, and basically apply sort of all-up operations to filter your log over multiple dimensions. So you start from an activity, you move to the resources, then you focus on a specific resource, then you look at the systems this resource has been involved on, and basically you every time intersect between this activity and this resource, between this resource and that system, so you can drill down to a very, very specific set of cases that fulfill certain characteristics. Okay, so now let's move to simulation very quickly, and maybe by the same token, I can show you the dashboarding capabilities because they are related to simulation. So we've covered automated discovery. So we have shown the structure of the process. We've used techniques from performance mining to spot bottlenecks and isolate them. And we've also briefly covered conformance checking by looking at cases that were not compliant. And in that particular example, we looked at the number of max repetitions, but it could have been a mandatory flow, a constraint, an SLA violation, a resource principle violation, like a resource constraint violation, like a 4i principle, etc. And then we looked at BPMN discovery and extraction. And we looked at different perspectives. So now let's come back to that as-is process that we discovered here, right? So what I'm going to do is that I'm going to open the same model, but I've just added pools and lanes, because this is what you would typically do, right? You've discovered your as-is and you prepare it for documentation purposes. So you add pools, lanes, and by the same token, you can add the simulation parameter that you can extract directly from your mining, so from the other plugin. So there's a range of simulation parameters. One that I mentioned before is the arrival rate. So here I'm assuming that I receive a new application every 30 minutes. The engine is quite sophisticated. So for example, it has a wide range of statistical distributions you can choose from to set your parameters, or different configuration opportunities. So what is relevant from a cost viewpoint is to specify the pools of resources that you have. So you see here I've got banker, banker manager, credit officer. And as I said, you can read this from the roles in your log. You see banker, banker manager, credit officer, and so on. You have to specify the timetables. So each of these resources would have a timetable and a capacity. So how many people you allocate for each, and what is the cost per hour. So once you specify that information, the cost per hour for each resource and the timetable. So here I'm using, for example, a standard arrival table for that resource. The offer manager has a separate timetable. You can see all the timetables here. So this is, for example, a 9 to 5. The offer manager has a 9 to 11 because they tend to manage all the offer only in that specific time frame of the day. If you have a bot, you can put 24/7, etc. So armed with that information, I can now, and there are of course other parameters that I'm not going to cover for brevity, you can simulate this model, right? So I go there and I simulate. Let me call it loan origination as is. As I simulate it, Apromore is going to generate an artificial log. So this is the beauty of bringing together modeling, simulation, and mining. That event logs and process models for us in Apromore are both first-class citizens. So I've generated a log. What does that mean? That is the log of my assist process as I have simulated. Then now all the process mining capabilities are at my disposal. So I could go and identify bottlenecks. I could animate, I could filter, etc., etc. But another thing that I can do is to launch a dashboard. The dashboard is going to put in a tab, the simulation tab, all the relevant statistics at an aggregate relevant that are interesting to assess a particular simulation scenario. So you've got the duration, you've got the waiting time, you've got the cost, and then you've got the resource utilization. And then you've got detailed statistics for each activity. For example, you can see mean, average, and max cost per activity, right? You can see those that cost the most, those that cost the less, the same with waiting time and duration. Now, what I can see is that I have a problem here. I have a role, a credit officer, who's almost saturated. As you know, resource utilization, the higher it is, the higher the chances that you're going to generate queues in your process. So the waiting time is going to increase. So, you know, they play one against each other, waiting time versus resource utilization. That's a basic principle behind Little's rule. So what does that mean? That if I really go ahead and implement my marketing campaign to push more my loan products, this credit officer, unfortunately, is not going to cope with that. So what I expect is that definitely I'm going to have a slowdown of the process. So the duration, which at the moment has an average of 3.4 weeks, is going to extend. And that's indeed what we can do. So I go back to the drawing board, my simulation, go to the arrival rate and say, look, let's receive now application 1 every 20 minutes. I save this in another version, or this could already be a what if. I see all the versions there. I select version 1.1 and I simulate again. So now this is a what if scenario. What if at 20 minutes, right? Apromore will generate the log again. That was my assist. This is my what if. And I could go on and drill down. But what I want to do is to launch a multi-log dashboard to be able to compare the two scenarios. So in blue, I've got my assist, 3.4 weeks. In red, I've got my what if, now on an average duration of 1.07 months. I have fully saturated the credit officer, so I cannot really cope with that anymore. And you see that the waiting times have increased. Now, the waiting times is 4.34 days on average compared to 3.57 days. So now the improvement assessment starts. There are different ways in which I could improve this process. I could try and allocate more units for the credit officer if I can afford. Or I could accompany the credit officer with a bot that automatically fetches some information that is relevant and pre-approves an offer for the credit officer just to validate. Or if possible, I could try and remove the credit officer altogether from the equation in select activities that I may automate. And basically, this is now an interactive part where you make your changes. Like, for example, here I have a version 2B of that process where I have added a bot, right? There's a bot here with a fixed duration of 30 minutes. So I've added to my pool of resources a bot with a given cost per hour and 1 unit. And then I can simulate that 2B and compare again with my scenario. So that's my 2B, right? Once you identify the most promising alternative, then you can go ahead and build a business case for implementing that intervention. So you see that now in my 2B, I've dropped the duration from 1.07 months in my what if to 1.28 weeks while keeping the new arrival rate. And of course, there's a range of charts and statistical tiles and tables that I can use to compare this. So for example, one that is typically interesting is the work in progress. Remember the number of active cases over time. So if I look at my ASIS, you will see that they keep growing as the queue builds up. But it is relatively stable. I can add the average here. So I can quickly edit that and add a reference line or an average, right? The average number of cases that are open. I have on average 181 open applications at any time. Right? So now I go back and I see with my what if, you see that the game changes. Look at how the queue grows. The number of open cases peaks at 400 around October, simply because I saturate the credit officer as a resource pool. And now in my 2B, that a number of active cases is much more uniform over time, and it is in fact even better than the original one where I had an average of 181 open cases. So that is basically showing me the evidence that this would address my problem. Okay, I will leave it at that in the interest of time and take any further questions and of course answer any doubts you might have. This has just been a quick presentation. I hope I've been able to make a point here that process mining, it's actually it's a valid approach that you can use to manage your business processes. So to discover, analyze, and improve them. And it is based on the evidence of data that originate from our own systems. And it is quite versatile, and it is for an analyst, as you are. So you are not throwing down the bin all the knowledge that you have acquired throughout your experience, your Lean, your Six Sigma, your business process engineering, design thinking, all these principles apply. The type of waste remain always the 7 type of waste, etc. But now you have a way to quickly find this, to quickly apply your knowledge so that you can focus on the more value-adding phase of BPM, that is the improvement part. And this is, at the end of the day, all that process mining is an enabler for you to accelerate improvement initiatives and do them in a more effective way.
And yeah, so just a quick one for everyone's benefit, Professor Marcello. So let's say if an organization is not doing a full-fledged BPM implementation, but they want to do this, what would you recommend? How do they do this? Do they go for a small POC, a POC, and then show value? What will be your recommendation?
So there are different stages of maturity. There are organizations that have already embarked into a process modeling journey that has already taken a few years, right? And now they want to take the extra step. But there are also organizations that can't afford to build and maintain large collections of process models. And for them, actually, the starting point could be mining. So the first point that I want to make is that you do not need to do modeling before doing mining. You can actually use mining, as I've shown, to start building your model collections. You see this model here, I actually extracted it from an event log. And then I started beautifying it by adding pools, lanes, and I took it even to the next level by simulating it. Then, to get started, even if you are a large enterprise, typically the safest way to do is to do a POC. We have a quite structured approach at Apromore to perform these POCs. We can do them quite rapidly. We follow a 5-phase approach. And we basically show how process mining can be done using your own data sets in the context of a core process where you know there are known problems, and we use the project to try and answer business questions you might have around the process, like why 70% of my claims take longer than 5 days to be handled, right? Now, the POC will do that, but it will also help the organization assess the level of readiness to process mine. And there are two sides of readiness. There is an organizational readiness and there is a data readiness. The latter means, do I have enough data? Is the data of enough quality? What is the effort required to put the data together? Simply put, I have been surprised over time by the fact that in the great majority of cases, you can actually find the data. It's just a little bit more hidden. It may require a bit more work to put it together. But remember, this data preparation is an exercise that you tend to do once and then automate, for example, through the ETL plugin.
Yeah.
The second point is organizational readiness. Are people going to be ready to accept the results of process mining? No, we are going to unearth potentially a lot of skeletons. And we might be able to do that quite fast, right? You need to have champions in the company that believe in the approach and they are going to take the results as a starting point for improvement. If you don't have this readiness at the organizational and data level, then process mining is not going to take off. And that goes with any project, right? Any initiative. So I see Clyde is asking whether we can simulate all gateways. Yes, we can simulate XOR and NOR, as well as different types of events.
Yeah, I think from where Clyde is coming, we probably don't simulate OR gateways in certain tools. It's just the XOR. So yeah, that's good to know.
Yeah, so you see that in this model, I had an AND, and I was able to simulate it. If I had an OR, I would have also been able to simulate it. It's actually a quite sophisticated simulation engine that, again, comes from our own research experience.
Okay. We've pretty much gone over time here. So we've got Max. Max, would you like to say anything? No, can't hear you. Okay. Well, thank you so much, Professor Marcello. That was really a fantastic presentation. Yeah, having seen Apromore maybe a couple of years earlier, and looking at it now, there's it has advanced such a lot, and it's really a pleasure to see this tool in that form. Thank you so much, everyone, for your time. And yeah, look, we keep a tab on our LinkedIn page. We've got some exciting webinars coming up next month and next year. And we will again probably get Professor Marcello back talking to us as the tool improves further.
Pleasure. It's always a pleasure to talk to the community.
Thank you so much, Professor. Thank you so much, everyone. We will end this call.
Thanks, Marcello.
Thank you very much.
Great evening.
Thanks very much.